So in this video, I'm going to be doing additional practice problems on circles. We've been doing a lot of practice sets on circles in the past few videos. And now this will consolidate all of them together, randomize the problems and all that to see if you got the concepts and required formulas down. Okay? Technically, this only really scratches the surface of what you can learn about circles. There's lots more things that a typical geometry class could go over, especially if you're in honors or something like that. Okay? So hopefully at the bare minimum, you can get these down. At least according to this book, this is all you need for the SAT exam. Those inscribed angles, central angles, the chords, the arcs, and all that stuff that we've been going over. All right? So with that said, let's begin this practice set. As always, please try the problems first yourself before watching me think through them and solve them. Okay? Now, what does this first one say? In the figure above, O is the center of the circle, and AB is a diameter. If the length of AC is 4 root 3, AC, let's start marking some stuff, is 4 root 3. And measure of ABC is 30, okay? What is the, actually BAC, that's what it is, yeah. What is the area of circle O? So to get area of circle O, we probably need to use pi r squared. So we need a radius. How can we get a radius from here? Is now the question. Okay, so AB is a diameter, okay, that's fine. So this is congruent to this, which is congruent to this. These are all radii, notice that, okay? It might be useful to mark whenever you see a radius. Length of arc AC, not chord AC. So notice I made a mistake there as well. AC is an arc, so out here, 4 root 3. Okay, how does that help us? And let me zoom in a little bit more so that it's a little more clear. Okay, hopefully it's not too zoomed in, but okay. If this arc is 4 root 3, do we need to use that actually? That's what I'm thinking. Because this is an inscribed angle. The arc intercept is CB. This is a central angle. So what's the measure of this angle? It should be twice of this. So this angle over here is 60 degrees. Maybe that will help us actually. If this is 60 degrees, then what's this angle over here? COA. That is 120 degrees, right? These two are supplementary. So that's 120. So this one must be 30 as well. Okay, does that help us over here? What are we trying to find? What's the area of circle O? Okay, so we need a radius. So this does help us because this is an isosceles triangle. Maybe we don't need this 4 root 3. It might be a distraction actually. Or is it length, does this mean arc? Actually, it didn't say, where did I read arc? I don't know where I read arc. The length of AC. So this, this is 4 root 3. My bad, okay? So we're on the right track now because this is an isosceles triangle. Remember there's that corollary, or you can use the isosceles triangle theorem. So let's just bring out one of the triangles. This is O, this is A, and this is the center over here, okay? This will bisect CA. So it's 4 root 3, so over here it's 2 root 3, and this angle was 30. This is 60 for sure then, and it makes sense because this would bisect this 120 degree angle as well. Okay, so this is a 30, 60, 90 triangle. Now it should be familiar territory. So if this is 2 root 3, then this over here is 2, and this over here is 4 by the special triangle. Okay, OA is a radius now. So pi r squared is pi times 4 squared, which is 16 pi. Answer is B. Okay, that's how I thought through that one. Be careful reading is basically more of the story for what I did wrong. I didn't technically do wrong, I caught it in the end, but read carefully. In the circle above, chord RS is parallel to diameter PQ. That's probably Q, so maybe let's mark parallel. If length of RS is 3/4 of length of PQ, and the distance between them, between the coordinate diameter is 2√7, so let's draw that. This is a right angle, 2√7. What is the radius of the circle? So, notice that this is a radius, and this is a radius as well. We probably need to use that, okay? Do we need to even use that? They're parallel. No, let's keep it in the back of our head though. Maybe it'll help us find some angles or something like that. Okay, if this is 2√7, the distance between them, length of RS is 3/4 of the length of PQ. So if RS is 3/4 PQ, PQ is the diameter, which is twice the radius. So let's even write this a little bit different. 3/4 diameter is twice the radius. PQ is the diameter. So that's RS. RS is equal to, this would cancel to that. So 3/2 lowercase r for radius. Okay? That's RS. Okay? Now, if we draw the triangle, one of them, okay, this is O, this is R, and this is again the radius over here. RO is the radius, right? This is 2√7. This, we just said RS is 3/2R. This is half of RS because again, this is the isosceles triangle. So this would bisect RS, okay? So we have this again. So it's back to that actually. So it'll be 3/4 R. Okay? Now we can use the Pythagorean theorem, right? So 2√7 squared plus 3/4R squared is R squared. And we are trying to find the radius of the circle, so we can do that, right? So this would be 4 times 7 plus 9/16 R squared is R squared. So 28 is, what is that? That's 16, what's 16 minus 9? 16 minus 9, that is 7, right? So 7/16 R squared, okay? So divide by 7 both sides, that's 4, and then multiply by 16 is equal to R squared. Okay, so R squared is 40 plus 24, so R squared is 64. So R is equal to 8. Answer is C. Let me double check. Yes, good. Okay, so you have to be able to see that these were radii. And then the key here was this is the diameter. Okay. In the figure above, the circle is tangent to the x-axis and has center -4, -3, which is the following equation represents the equation of the circle in the xy plane above. Okay, so it should be, the center is -4, -3, so it should be x plus 4 quantity squared plus y plus 3 quantity squared. So let's see if we can eliminate anything. Eliminate this, eliminate this. Now what's the radius? Well, it's tangent to the x-axis, right? So what's this point over here? It will be -4, 0. Right? So what's the radius? It's length of 3. 3 squared is 9. Answer is A. Remember, it's R squared over here. Figure above shows a semicircle with lengths of the adjacent arcs. This, I feel like we did a similar one like this before in the previous problem sets. But anyway, if the value of x is 42, what is the value of A? Okay, so if x is 42 degrees, how does that help us? I'm already thinking, we know the length of this whole arc, and we know the length of this arc, the specific one over here. The length of this arc, this whole thing over here is a semicircle. The circumference of a full circle is 2 pi r, right? So half a circle is pi r. So pi r is, what's the sum of all these? 1, 2, 3, 4, 5. That's 5a's. 5a plus 7, 8, 9, 10 plus 10. Okay? That's one equation. And then over here, if x is 42, so 42 over 360 times 2 pi r is equal to a plus 4. Okay? 2 pi r is the full circle, and we only want a fraction of it. The fraction is 42 over 360, because this is 42 degrees. The whole circle is 360 degrees. So from here, we can solve for a, because we have two equations, two unknowns, system of equations. Okay, but maybe let's simplify a bit first. Okay, and then how can I simplify this over here? By 6, right? So 7 by 6, that is 30. Okay, so this is, okay, so pi r is a plus 4 times 30 over 7. If I move this 7 over 30 to the other side, it's 30 over 7, right? And then we have pi r still. And then pi r is equal to 5a plus 40. So let's set them equal to each other. 5a plus 10, sorry, is equal to 30 over 7, a plus 4. Okay, now we can solve this for a. Let's multiply both sides by 7. 35a plus 70, just to get rid of that fraction. So then 30 times a plus 4, I can distribute the 30. 30a plus 120. Okay, so 5a is 50, a is 10. Answer is D. Okay, so this one you had to set up two equations. At least that's how I thought of it. So your algebra skills still need to be good in these geometry sections, clearly, okay? In the figure above, the length of arc AB is pi. What's the area of sector OAB? Okay, there's a very quick way to do this, and there's a slow way to do this, okay? The quick way is if you know how to do things in radians. You can get it a lot quicker, but let's assume you don't know. So I'm going to do it the slower way. The length of the arc is pi. So what's the formula for arc length? The full arc length is the circumference of the circle, so 2 pi r times a fraction of it. So 36 over 360. Okay, this is a tenth. We can simplify. Okay, and then this would be a 5. Okay, and then this would cancel to a 1. Okay, so r is equal to 5. Okay, now area of the sector, so pi r squared. This is the area of the full circle, and then we only want a fraction of it, 36 over 360 again. Okay, so that is, this is again 1/10. Okay, and this is pi times 25 over 10. This is 2, this is a 5, so this is 5 pi over 2. That's the area of that sector. Okay, again, it's a little faster if you can do things in radians, but this book didn't teach you that. I don't think the SAT exam expects you to know it then, if that's the case. Okay, what is the area of the circle in the xy plane above? I think it must be a typo, but how do you get the area of the circle when it's in this form? We gotta complete the square. Okay, so x minus 4x plus minus 4 over 2 squared. Then we have to add it on this side, minus 4 over 2 squared, plus y squared minus 6x plus minus 6 over 2 squared. And then we have to add it on this side, minus 6 over 2 squared, and then minus 17 still, okay? This is x minus 2 squared plus y minus 3 squared. Minus 17 is equal to, that's minus 2, square that, that's 4. This is minus 3, square that, that's 9. Okay? So this is x minus 2 squared plus y minus 3 squared is, that's 13 plus 17, which is 30. Okay? So this is your r squared. Area of the circle, pi r squared, which is pi times, we just said r squared is 30. 30, so 30 pi. Which the following is an equation of a circle that has diameter of 8 units and is tangent to the graph of y equals 2. Well, diameter is 8, so that means radius is 4. That doesn't help us because all of these are 4 squared, which is 16. So now we got to figure out tangent to the graph of y equals 2. So maybe let's sketch this out. What is this line, y equals 2? It's a horizontal line, right? So let's say this is y equals 2, the horizontal line. Okay, the circle is tangent to it. That means the circle must be like this for it to be tangent at right there, right? Or, hopefully you can see the different color. Draw it a little bigger as well. It'll be like this. It's tangent to the graph. So it's either right above or right below. Which one is it, though? Well, let's use this now to our advantage. Diameter of 8 units. So radius is 4, so that means you have to, from y equals 2, since it's a tangent there, you have to go up 4 then. That would be 6 then. That's the y coordinate. Is that one of these? Clearly not, right? So that means we have to go downward by 4, which is minus 2. Okay, so over here, your k is, in the hk, the center, k is, so this is minus 2. Minus 2. K is minus 2. So that means we can eliminate this one, because it's, remember, y minus k, so it's y minus negative 2. Cross that out, cross this out, cross this out as well. Answer is A immediately. Don't have to even find the x coordinate. And maybe that was the point. You don't have to find the x coordinate of the center. Okay? That's how I thought through this one. It's actually pretty easy if you were able to think that through. In the figure above, rectangle, this guy, is inscribed in a quarter circle that has a radius of 9. If PQ is 7, what is the area of rectangle OPQR? Okay. How can we do this? Well, notice this is a radius over here. Radius of 9, right? And for a rectangle, this must be a right angle over here and a right angle over here as well. We can focus on one triangle. Okay, so PO, do we need PO? We do, because we need area of the rectangle. We can find PO by which theorem? Pythagorean theorem. PO is square root of 81 minus 49. Okay, which is, what is that? Square root of 32? Which is, that is 16 times 2, right? So 4 root 2. That's PO. So the area is base, which is OR, which is congruent to PQ because it's a rectangle, so 7 times the height we just said is 4 root 2. So it's 28 root 2. Pretty easy, actually, this problem. In a circle with center O, the central angle has a measure of 2 pi over 3 radians. The area of the sector formed by the central angle AOB is what fraction of the area of the circle? This is actually really easy because that formula that this book wants you to memorize is actually what this question is trying to ask you. Okay? So the central angle is 2 pi over 3. Okay? What's the central angle for a full circle? Isn't it just 360 degrees, or is it's 2 pi in radians? So this is 1/3, which makes total sense. 2 pi divided by 3, that's 1/3, is it not? That's the answer. Very simple. A wheel with a radius of 2.2 feet is turning at a constant rate of 400 revolutions per minute on a road. If the wheel traveled k pi miles in 1 hour, what is the value of k? Okay, So this is probably a calculator question because you have to convert this big guy over here. Let's be careful. Let's use the units to our advantage. Whenever it's a word problem, something like this, especially where conversion is needed, I always use the units to make sure I, at least at the bare minimum, get the units right so that I'm likely on the right track to get to the correct answer, numerically. Okay, so we'll travel k pi miles in 1 hour. What is the value of k? Let's find it in minutes first. Okay, so a wheel with a radius 2.2 feet is turning at a constant rate 400 revolutions per minute. So if there's 400 revolutions per 1 minute, okay? Now, in 1 revolution, how much distance is it? It's 1 circumference in 1 revolution, right? So, what's the circumference of the circle? It is 2 pi, radius is 2.2 feet. 2.2, so let's put feet over 1 revolution. So it travels this much distance in 1 revolution. 1 revolution is 1 circumference. That's what happened here. So the revolutions cancel, okay? Now, what else do we need to multiply by? Okay, revolutions per minute. So we now need to, looks like, convert to miles an hour, okay? So how many minutes are in 1 hour? That is 60 minutes per 1 hour. Okay, so the minutes would cancel. And then finally, we're in feet, we need miles, right? So 5280 feet in 1 mile. The feet would cancel. So then our units left are miles per hour, which is what they require here, right? Let me double check. Let me actually punch it into a calculator to get this right. We can leave the pi alone, right? So 400 times 2 times 2.2 times 60 divide by 5280. So this is 20 pi miles per hour. So then your k is 20. Okay, so again, this helps me out. So if it helps you out to write the units out and do unit analysis like this, please do it. I would recommend it actually to make sure you at the bare minimum get your units right so that you're probably on the right track. Okay, if you don't include the units, you might be randomly dividing and multiplying things and you get lost. Okay, you might have accidentally flipped these two, for example, 1 hour over 60 minutes instead of 60 minutes over 1 hour. So this is why it helps out to write the units, at least for me. All right, that's it for this problem set. Hopefully this was helpful. This is a little bit longer video as usual for these review sections, but hopefully you saw the different types of problems that the SAT exam could possibly ask, at least according to this publisher. All right, as always, please like and subscribe if you found this helpful in any way. It really can support this channel out. All right, hopefully see you in the next video as well. Bye.